A very warm welcome to all of you. Myself Rajan Choudhary, Professor in the Department of Civil Engineering, Indian Institute of Technology, Guwahati, instructor for the NPTEL MOOC course Pavement Construction and Technology funded by Ministry of Education, Government of India. Today we will be discussing the lecture 23 under the module 10 where we will discuss about the aspects related to pavement roughness and its measurement. At the very beginning, I would like to acknowledge the use of text, informations, graphs and images sourced from various textbooks, codal standards, general articles, reports, newsletters and public domain searches. Now, as the word itself indicates, it is the smoothness or the roughness of the surface which is very important. So, if I call it as a pavement is rough, I can call that the pavement is not smooth. So, in the similar fashion, we measure the quality of this pavement in terms of its roughness, and what is usually conveyed with the pavement roughness is the pavement roughness or unevenness is a key indicator used to describe the irregularities of the pavement surface. We have seen in previous lectures how during the construction of individual layers the surface levels were ensured, then the unevenness or regularity was ensured, and finally once the pavement surface is ready, then also the final surface, wearing surface which will be available for the user needs to be ensured for the roughness aspect. So, pavement surface roughness or unevenness is a key indicator used to describe the irregularities of the pavement surface. Specifically, we are talking about the wearing surface. On the top, this exercise is done that adversely affect the ride quality of vehicles, because this can a good smoothness or a good evenness can be achieved, or a lower roughness can be achieved if the good practices are ensured from the subgrade construction itself. Then only it is possible to get a good riding quality or a good smooth surface on the top. So, otherwise if a surface is smooth, it adversely affects the ride quality of vehicles and the comfort of the road users. So, we will discuss these aspects related to pavement roughness considering the IRC SP 16 2019 special publication, which is guidelines on measuring road roughness and its related norms. So, we can say an increase in road roughness leads to higher road user cost, because it will definitely increase the vehicle maintenance cost, the fuel consumption, even the time for travel. It will reduce the speed which can be adopted on that particular surface. And in addition to this, it will make your ride uncomfortable and often drawing criticisms from the users. So, this is the functional requirements are not met if the surface is rough. So, for the user it is a very important aspect to have a good smooth surface. So, roughness typically refers to surface deviations which are there from a true planar surface with characteristics dimensions that influence ride quality, because here the role of vehicle will also come into picture. Conversely, smoothness represents the absence of some such deviations. That means, if this surface is smooth, then it is we can say it is less rough or the unevenness is less. As a critical indicator of pavement performance, even a newly constructed pavement, in addition to its structure requirement, should meet up this functional requirement that the surface should be smooth enough. So, as a critical indicator of pavement performance, and we can, as we in our previous lectures we discussed about the structure evaluation where we discussed the residual life. So, that is one way of evaluating the pavement performance. This is another way where we are trying to judge the performance in terms of the riding quality. So, a critical indicator of pavement performance, the term roughness and smoothness are often used interchangeably. Now, from where this roughness arises, as we mentioned, it is from the bottommost layer construction, where we start doing the construction of subgrade layers, followed by our granular layers, bounded layers, and then our wearing courses. So, at all these layers, regular ensurements in terms of the surface levels or surface irregularities has to be maintained, so that finally on the top you can get a smooth surface. So, it says road roughness mainly when can it arise either from built-in irregularities, so during the construction itself caused by construction defects, or from surface distortions if there are certain distresses are there during the course of construction itself by the construction vehicles, or if the traffic is not controlled during the construction itself, is the traffic is using those underlying layers, then those layers can get distorted during the construction itself. So, these distortions later on get reflected on the top layer in the form of roughness. So, this can either from built-in irregularities caused by construction defects or from surface distortions that develop over the time due to the consolidation. If they are not properly compacted, then consolidation or densification takes place, or displacement of the pavement materials. If the pavement materials are not strong enough, they may get displaced. So, there will be a distortion of those materials. So, then there will be an occurrence of roughness on the top. So, these may be possible causes for having a rough surface or for the introduction of roughness on the surface courses. So, roughness is an important aspect of pavement surface, and why? Because it impacts various factors. Few important are safety of the road user. Now, this is another very important aspect we can say, like vehicle vibrations from road roughness can impair driver performance. It can increase the driver fatigue. If it increases the driver fatigue, it increases the chances of accidents also. As prolonged exposure may cause fatigue. If he is exposed to a rough surface for a longer duration of time, it will definitely lead to fatigue, and this will increase the likelihood of accidents. The vehicle suspension, this also plays an important role, also influences this effect, because how good the suspension is, that will reduce this particular impact and will reduce the fatigue also. So, when vibration, even the vibration frequency aligns with the vehicle's natural frequency, because when you travel on these surfaces, undulated surfaces having different wavelengths and having different frequencies, when they align with the natural frequency, the roughness may appear to be reduced, but if it goes out of way, then the roughness is amplified. So, this is with respect to the suspension also, it plays a role. So, it is highly important for the safety of the users, because otherwise if fatigue is there, definitely it is more problematic, and in due course of time it increases the chances of accidents. Roughness can also lead to a significant reduction in the loss of braking force or the skid resistance. This is another concern, and this roughness may be varying in your wheel paths. That is another concern. So, variation in roughness between wheel tracks further compound the problem. If you have the roughness which is different in the wheel paths, then it further compounds the difference, because then you do not have a good contact of your vehicle tires with the road surface because of the roughness. So, then it leads to differences in braking and sliding forces, which further exposes vehicle to unequal friction levels on each side, creating a serious safety aspect. So, this roughness which may be different on the wheel paths, even if not different, same, then also this roughness will reduce the frictional resistance, and it will affect your safety of the movement. Now, vehicle operating cost, this is another important factor. Vehicle operating cost, usually what it comprises, it comprises of your fuel, oil consumption, tire wear, maintenance and repair, and depreciation. So, these are some of the important things which comes under vehicle operation cost. They significantly increases if the surface is rough enough or the pavement is having high roughness. So, road surface roughness is a key factor influencing vehicle operation cost, as a higher roughness increases fuel consumption at a given speed and reduces overall travel speed. This is because when roughness is high, the travel speed comes down, and then the fuel consumption is increases. So, and it further increases the requirement of repair, because with the rough surface there may be frequent chances of requirement of repair required for different categories of vehicles. Another aspect is the vehicular riding comfort. Riding comfort, definitely if you have a rough surface, the riding comfort becomes poor. So, a vehicle's riding quality is influenced by travel speed. Definitely, if you have a rough surface, you will be traveling at a lower speed. Its dynamic characteristics, how the vehicular suspension systems are and the spectral properties of the road surface, as I mentioned in terms of the wavelengths of different irregularities and their frequencies. So, assessing the ride quality and roughness through vehicle response depends largely on the speed and vehicle dynamics. So, this how the driver will get affected or the user will get affected highly depends upon the surface roughness, the vehicle dynamics and the speed on which it is moving. Vehicle speed, definitely, as we discussed, over a rough surface, the vehicular speeds are expected to be lower compared to what it can be there on the smooth surfaces. So, various studies on the roughness speed relationship have established a negative correlation, that if roughness is more, then it definitely leads or it means that the users will move at a slower speed. Now, how do we measure these roughness of pavement surfaces? Normally, two systems are used. We classify the different systems which are used for measuring pavement roughness into two systems, broad categories. One is profilometric systems and second is response type road roughness measurement systems. So, first of all, the one where what is the profilometric systems. So, these systems measure road roughness based on the surface profile of the pavement. So, the surface profile is captured and it is compared with respect to a planar surface, and then considering a simulation of a standard vehicle driving at a standard speed, some roughness index is derived. So, they include advanced, and specifically what are included under these profilometers are, we have some advanced profilometers. You can see this is a laser profilometer which is attached in the front of this particular vehicle, that captures profiles using lasers and accelerometers, as well as there may be certain walking profilometers. So, this is one typically known by the name of dipstick. So, this is again one profilometer which is walking profilometer. So, you need to walk along with this profilometers. This particular category of profilometer is attached to the vehicle at the front or the rear end, and then it captures the profile of the road. The second is, so they directly captures the profile of the road on the basis of that, and then with the simulation model at a particular simulated speed, it measures how much the amount of accumulation of the vertical movement will be there with respect to the total travel time, and that is given in terms of some index value. Second is the response type road roughness measurement systems. So, this is another very commonly used systems, and what is there? These systems evaluate road unevenness based on the dynamic response of a vehicle. So, here you can see this is one which is known as a fifth wheel bump integrator. So, equipment under this category includes the fifth wheel bump integrator. This is the fifth wheel bump integrator. And another is the automated road unevenness recorder. This is the one which was indigenously developed by Central Road Research Institute, New Delhi. And then we have car axle mounted bump integrator and accelerometer based systems. And what these systems do, they measure the response of this roughness of the surface and with respect to the total length travelled. Now, further we will discuss some of the important features of these response type road roughness measurement systems. As I mentioned, this is the one which is very commonly used. You can see this is the fifth wheel bump integrator which is towed to a particular vehicle. So, it is a response type road roughness measuring system which consists of a trailer towed by a vehicle. So, this is a vehicle to which this particular roughness measurement system is towed, and it uses a standard pneumatic tire. You can see with having a standard pressure to be filled up, mounted on the trailer chassis, and you have a heavy weight so that the movements are not getting transferred to this rear chassis which is there. And this is trailer chassis supported by leaf springs. There are single leaf springs which are there in this particular one, and dampened dashboards to minimize vehicle induced motion. Any vehicle induced motions are dampened in this particular. And what is done here is a mechanical integrator records the cumulative vertical displacement. The cumulative vertical displacements which are there are recorded of the wheel relative to the chassis. So, this is what is done in this particular one, while a distance measuring unit tracks the travel distance. So, we are having the vertical displacement, cumulative vertical displacement, which is monitored along with the length which is travelled. So, the roughness index is calculated as the ratio of the cumulative vertical displacement to the distance travelled. So, lower this particular value, the smooth the surface is, higher this particular value, the rough the surface is, and this particular one is normally known as roughness index, and the unit is in terms of mm per kilometer. For this particular vehicle, the fifth wheel bump integrator, it has to be driven at a speed of standard speed of around 32 km per hour, and especially this is moved along the wheel path of that particular lane for which we are measuring the roughness. And definitely these are certain equipments which needs to be calibrated regularly with high precision equipments, especially the profilometer based equipments. So, usually we do a calibration in a period of 2 years, or if a travel of already 5000 kilometer of measurements have been done. So, whichever is earlier, the calibration has to be carried out regularly. The other category is car axle mounted bump integrator, again very similar to the fifth wheel bump integrator, but here the important part is the bump integrating unit is mounted on the rear portion of the vehicle or floor of this particular vehicle, and in this particular case here you can see the bump integrator is fitted to the rear axle. This is the bump integrator which is fitted to the, and it is mounted on this particular floor of the vehicle. So, this is, you can see this is placed here and it is fixed to the rear axle. Now, what it records, the differential movement between the rear axle and the vehicle body. This is what is captured through this particular wire, is captured through upward motion of a wire. Now, this particular upward motion is converted into unidirectional rotational movement of the integrator pulley. So, again it simulates or it accumulates the vertical motion which is taking place between the vehicle body and this particular one which is mounted on the axle, and along with it the length is recorded. So, again it gives the unevenness index or roughness index in mm per kilometer. And the other category is the laser based profilometer systems. These are the most accurate systems which are widely used, preferred for the road roughness measurement systems. These are high speed systems. They measure the pavement roughness response using laser beams which are mounted either on the front end or can be at the rear end also, and typically two which are there, and they capture both the longitudinal profiles of both the wheel paths. So, usually you have two wheel paths as so in that case you can capture this particular one. Otherwise, when you are using the fifth wheel bump integrator, it is preferred that you move that wheel on the wheel paths itself. And in this particular system, what is there, vertical displacements are recorded through these sensors, and they capture for the both the wheel paths. And here this particular the profile which is captured is then these corrected profiles are simulated through a standard car model where at a standard speed, and then you directly get your the unevenness index in terms of the international roughness index. So, two units are there. One is the roughness index or unevenness index which we get from the response type road roughness measurements, and second is this international roughness index. So, this can be obtained for both the wheel paths, and the unit of this international roughness index is meter per kilometer. So, here you can see this is a laser for the left wheel path, this is for the right wheel path. So, as I mentioned, there are two units which are there widely used in this pavement roughness computations. One is international roughness index. Globally it has been preferred. It is a standardized and widely used measure of pavement roughness representing the vertical response of a simulated quarter car model. So, this is what for the profile which we have, the measured longitudinal road profile which we get from the profilometers, that particular one is subjected or simulated through a quarter car model to get the vertical response, and this is simulated at a speed of around 80 km per hour, and the vertical response is computed for this particular model, and this is defined as the ratio of the circulated suspension motion or response to the distance travelled. So, whatever distance, and this is expressed as the reference average rectified slope. So, this response which we get from a simulated quarter car model with respect to the, when simulated at a standard speed of 80 km per hour, with respect to the total length travelled, we get the slope which is reported in meter per kilometer or inch per mile. So, the one which is widely used in India is in terms of the meter per kilometer. So, from these profilometers we get the values directly in terms of the International Roughness Index having a value of meter per kilometer. Whereas, in case of the roughness index or the unevenness index, which we measured with the response type road roughness measurement systems, which were like fifth wheel bump integrator or car axle mount bump integrator, where what we measured the response of that particular one to the roughness, and this accumulated response with respect to the total length was there directly. So, here we measured the dynamic response of vehicles to the road surface through some mechanical or accelerometer devices. So, there what we did the cumulative summation or the summation of the vertical undulations, deformations with respect to the length of. So, it is the cumulative undulations per unit length. Now, this is what in case of response type road roughness measurements, and as I mentioned there, in that particular one the unit is typically mm per kilometer. Whereas, in case of internet, now there have been through certain studies a relation have been also established between this roughness index in terms of International Roughness Index and unevenness index, and one is the one which is given specifically for IRI values 17. 17 is a very high IRI value. So, it says roughness index is equals to 630 into International Roughness Index raised to power 1.12. So, this is this relation can be further used. So, we can calibrate these response type road roughness measurement systems with the high precision profilometers, and we can correlate the roughness index or unevenness index with the International Roughness Index with these expressions. Now, these different measurement systems can be put up as per the precision which we get out of it. So, normally they are divided into 4 categories. These are class 1 precision profilometers, specifically mainly they can be used for calibration purpose or other profilometer methods. Response type measurement systems, as we have an example of fifth wheel bump integrator, and then definitely the response can be in terms of the subjective ratings. I can drive on the surface and can give some subjective rating that this surface can be in a scale of say 1 to 5, where I would like to rate in terms of the, say I can say if the surface is to be good enough, I can rate it to say 1, or the surface is poor, like this way, whatever manner in a subjective rating is decided. So, the class 1 profilometers, these are the instruments that have the highest standard of accuracy. Specifically they directly measure the profile, and they are used for calculating the International Roughness Index, and are a series of accurately measured elevation points are there, because the important part is how accurately you measure the profile of the road. So, for this particular one you need to have a short interval. So, here it can say the elevations are measured at sampling intervals less than 250 mm. So, you have these laser profilometers which can do this particular exercise with a precision of less than 0.5 mm. For very smooth pavements using even walking speed profilometers, this is a dip stick which is getting used. So, it is a dip stick. So, this dip stick can be used, and this is a walking profilometer. So, here what is there, that they are sampling intervals, you are measuring the elevations at intervals less than 250 mm, and the accuracy is even less than 0.5 mm. So, these are high precision profilometers, and once this profile is there with you, then through your that simulation model at a simulated speed, you get the cumulative suspension with respect to the length, and you get your IR RI values. So, this is an inbuilt one, you directly get your values in terms of International Roughness Index. However, for high speed road profilometers such as laser profilometers, they can even give you better accuracy than what is mentioned under these class 1 profilometers. They can have sampling intervals less than 25 mm with a vertical measurement resolution of less than of 0.1 mm. So, this is they go with very high resolutions also in that case. So, then we have other profilometer systems are also there. They have precision lesser than what compared to the class 1 which was there, and specifically they say that the sampling intervals should be of maximum 500 width, and this particular precision should be less than 1 mm. So, this is again it comes for the walking profilometers also in that case. However, for high speed road profilers, the longitudinal sampling rate is greater than 25 mm to 150 mm, because this the high speed profilometers which travel, they usually have better than this particular one, and the resolutions ranging in the range of 0.1 to 0.2 mm. So, these are much better than what we are expecting. So, then comes the response type road roughness measurement systems. This is the precision 3 category which we have. So, all response type road roughness measurement systems belong to this particular category where you have these car axle mounted roughness measurement systems also. So, where the dynamic response is of the vehicles to a road surface is measured using any other mechanical or electromechanical process. This is the fifth wheel bump integrator which we have. So, the estimation of roughness index for this response type road roughness measurement systems is made using correlation equation after calibration with. So, these equipments needs to be calibrated as I mentioned, because with the time and with the travel which they do for their measurement systems, we need to calibrate, and we can calibrate it with precision 1 and precision 2 equipments in that case. And then comes the last category which is there is in subjective evaluations of the roughness, where the physically drives on the roads and makes regular, you can make these visual surveys can be made in this particular one. So, this is another way, usually because this is not practically possible and this gives a subjective one. So, we will prefer to go the commonly used, say the class 3 type of precision measuring roughness measurement systems, or for calibration part, and as we have now nowadays laser profilometers, good laser profilometers are available. So, we go with the measurements with these laser profilometers also. Now, what is the permissible? Now, you have these unevenness index with you, you have the international roughness index values with you. So, what are the desired permissible limits for different kind of surfaces for different categories of roads also? So, here as per IRC SP 16 2019, it says that the maximum permissible values of roughness for expressways, high speed corridors, national highways and state highways, it says, because typical surfaces which are used in the construction on the top, because we are measuring with the top, it says when you have these bituminous surfaces of bituminous concrete, stone matrix asphalt or semi dense bituminous concrete, for a good surface, because when initially it is constructed, the surface is to be put under the category of good, as we divide those sections into uniform sections, as we discussed in the previous lectures on structure evaluation, that the sections can be divided into good, fair and poor in that case. So, here if a section is to be taken as good, the roughness index should be less than a value of 1800 mm per kilometer, and the international roughness index should be less than 2.5. Whereas, if it is fair, it is in this particular range of 1800 to 2400 roughness index, and where it is poor, it is greater than 2400. So, this is what when you have high speed of corridors or which is there. And if there is another case, if you have for say roughness for major district roads and other district roads, so you will have different kind of surfaces there. So, you can have a surface dressing, you can have an open graded premix carpet, a mixed seal surfacing, a semi dense bituminous concrete, and in some cases you can have bituminous concrete also in these lower categories of roads. So there also, see, we can see when it is for expressways, national highways and state highways, the requirement was of the roughness index was less than 1800, but when for lower categories this requirement has raised. So now it is less than 2000. So we have again for good, fair and poor these recommendations which has been given by IRC SP 16. Now which particular one can be picked up for which what type of category, this can be also worked out, because now you have a good range of measurement systems available for monitoring the pavement roughness. So the choice of whether you can use a fifth wheel bump integrator or automated road unevenness recorder is there, or a car axle mounted bump integrator is there, any other advanced technologies like laser profilometer can be used, depends upon the size and extent of the road network to be worked out. Now we will see specifically in terrain areas, plain terrain areas where roads are in average to poor condition, average traffic speed is normally in the range of 30 to 40 km/h. There we can use this fifth wheel bump integrator, because there we saw that that equipment has to be run in a speed of around 32 km/h. So it is possible to run those fifth wheel bump integrator at if the speeds are not very high. But if you have these high speed corridors, the vehicles will be moving at higher speeds, is typically more than 60 km/h, even in your when it is in your fair or poor conditions also. So then the slow speed precision equipments or the roughness measurement systems cannot be used, and there what we will prefer? We will prefer the laser profilometers or the ultrasonic sensor based profilometers, which falls under the category of the class 1 and class 2. So they particularly are used for high speed corridors. Now again a guideline has been given for the selection of appropriate road roughness measurement systems in different operating conditions. Like it says, when you have low speeds from 10 to 40 km/h and the type of terrain which is there, plain terrain, rolling terrain and hilly terrain, this is with respect to the country slope which is there. So if you have a plain terrain, you can use the fifth wheel bump integrator or automated road unevenness recorder can be used, and a car axle mounted bump integrator can be used. For rolling also it can be used. For hilly it is a car axle mounted bump integrator only, which is preferred, with multiple speed calibrations have to be done, because then it has to be run at different speeds. So calibrations has to be done for different speeds. Now similarly, if you have a median speed range from 40 to 60, then here it says for laser profilometers also, it says for ultrasonic sensor based profilometers also. So these are profilometers, this is again car axle mounted bump integrator, or these are accelerometer based certain roughness measurement systems, they can be used. For higher speed, always we prefer to go for laser profilometers or ultrasonic sensor based profilometers. So these are the one which are typically on. You normally don't have in hilly regions speeds more than 60 km/h, design speeds typically. And again in addition to this particular one, they says that how much runs have to be done for this particular measurements for different categories. So it says if a single lane road is there, intermediate lane is there, double lane is there, multi lane is there, and if you are using this particular one, because if I am using laser profilometers, it can capture the roughness of both the wheel paths. So I can go for one single run for one lane. So for every lane I will go for laser profilometers, because it will be able to capture the roughness for both the wheel paths. But if I am using a fifth wheel bump integrator, then it is a single run each lane, because and specifically we will prefer to one which is more distressed, or the outer lane which may be preferred in each case. So and these are accelerometer based, one single run each lane can be there. Now it says for roughness measurement systems with fifth wheel bump integrator, the fifth wheel should preferably follow the wheel path. This is an important aspect. Again, while making use of this, you need to work it out. You have to have some better control, because it should follow the wheel path with at least one measurements per lane. So as I mentioned, at least one measurement per lane has to be there. In the case of car axle mounted bump integrator, that the vehicle's outer wheel travels on the wheel path. In this particular case, as because there it goes in the middle of it, but in case of car axle mounted bump integrator, it is always preferred that the vehicle's outer wheel paths wheel traverse on the wheel path, outer wheel path. So, and as I mentioned, walking speed class 1 equipments are generally used for calibrating these particular ones, validating the roughness data. And for this, say if you are using walking profilometers, you have to be very careful, and you will do for small stretches because you will walk with those profilometers. So, for small stretches we can carry out those exercises with walking profilometers, and then that particular roughness index can be compared with your these response type road roughness measurement systems to calibrate those systems. The roughness again, in what manner the roughness results can be reported. Here again a standard format requirement is there that if you are using any these response type road roughness measurement systems, and if you have basically nowadays this kind of exercise is done at least when you have a 2-lane road and you have a multi-lane road. So, it says if you are working with the fifth wheel bump integrator, it says individual lane buys, and it can be in terms of roughness index or converted to international roughness index, because IRC SP 16 gives requirements both in terms of your roughness index as well as in terms of your international roughness index. So, this can be reported in both the terms in that case, but for that particular one you need to have that calibrated one. Now, for laser profilometers or ultrasonic sensor based profilometers, individual lane wise and average IRI are converted, because then both the wheel paths are there. So, you can take an average in this particular one, individual lane wise. So, this is again a requirement which is given with respect to how the results will be reported. The results will be either reported in terms of roughness unevenness index or in terms of the international roughness index. So, this is all about the roughness measurements of the different sections by using different equipments. Specifically, we have the profilometers, high precision equipments, also we have the response type road roughness measurement systems. Thank you so much.